Hello, I'd like to welcome you today to our introduction to AWS. And today it's presented by Simone Brunozzi. And with that, I will hand it over to our first presenter, Natalie Serwicki. Natalie, you have the floor.
Thank you, Aurora. Hello, everybody. My name is Natalie Serwicki. I'm a marketing manager here at Amazon Web Services, and I'd like to thank you for joining us today for our introductory webinar. I have the pleasure of introducing you to our presenter today. Simone Brunozzi is a senior technology evangelist with Amazon Web Services, and he has been at Amazon for about 5 years now. He has been an evangelist for AWS all over the world and is currently based in San Francisco in California. And with that, I'll hand it over to you, Simone.
Thank you very much, Natalie and Aurora. And hello, everybody. I'm very happy to be here today. So what we will do today is to provide you with a brief introduction to Amazon Web Services, or AWS as we like to call it. And of course, as they already told you, you can ask us for questions in the Q&A panel. And of course, at the end of this presentation, I will try to answer some of them, and hopefully I will be be able to answer the most common questions or items that you would like to clarify. So let's get started. First of all, what is Amazon Web Services? So the mission that we have is to enable businesses and developers to use web services, what people now call the cloud, to build scalable, sophisticated, reliable, and cost-effective applications. And this is something that people are already using all around the world. We have a really huge number of customers, now north of 1 million customers. We power the most popular internet businesses. I'm sure that many of you recognize most of those names: Airbnb, Animoto, Foursquare, Netflix, Instagram, Dropbox, Heroku, etc. And we also power many enterprise customers. Some of them have been recently in the news. We had some events in San Francisco and New York recently, and some of them were also presenting on stage with us. And I particularly like the stories from NASA or Shell or Samsung, because they really tell us how the power of cloud computing is enabling them to do things that were not possible before. And just to convince you that we are really big now, just to give you a quick metric to get a sense, each day we add the equivalent server capacity that used to power Amazon.com in 2003 when it was a global 5.2 billion enterprise company. So that same amount of server capacity and storage capacity, we add it every day to Amazon Web Services. And we also keep innovating very fast. So almost every week there are a few new services or new features that we announce. In fact, it's sometimes tough for evangelists like myself to keep up with the latest and greatest about Amazon Web Services. But let's start by introducing Amazon Web Services now. Let me try to give you a sense of what we are talking about. I don't know if you ever heard the term utility computing. In essence, by utility computing, people mean that you have computing services, compute, so virtual servers, databases, storage, load balancing, and other functions. And you use them on demand. You pay them as you go, and they're always available for you. So whenever you need that capacity, you can request that capacity either by using APIs or you can use a management console that we provide on the web. So there are easy tools and visual tools, as well as low-level, hardcore technical tools for the tech savvy. And we also have a global presence. We have many regions around the world. One of them that you see dotted is the GovCloud, and that one is specific for government agencies in the US. But all the others are available for any customer in any country in the world. And when you sign up for Amazon Web Services, you instantly have access to all of those regions worldwide. So for example, if you want to launch a web infrastructure in Australia or in Japan, you can do it immediately. There's no need to negotiate other contracts or to talk to a representative. The moment you sign up, and you can easily do it online in just a few minutes, you have access, instant access to this infrastructure worldwide. And every region, just to explain what a region is, Every region is a set of data centers. We divide those data centers logically in what we call availability zones. Now, a question that I usually get asked is, why should a customer know about the availability zone? Why Amazon is exposing this detail? Well, the reason is by using specific availability zones, you can architect your infrastructure in such a way that you take advantage of running servers and using storage across multiple data centers. And this is a very important principle in architecting for high availability. Just to give you a better idea, and of course, we also have edge locations. Those are endpoints, additional endpoints, in addition to the data centers and availability zones that we have, that you can use to deliver content to your customers. So to give you an idea, if you have, for example, the region in Europe, and you want to launch EC2 instances, those are virtual servers, you can launch them, for example, in availability zone EU West 1A and in availability zone EU West 1C. Those would be physically isolated data centers, in our case, in this case, in Ireland. And by using that command there that you see, EC2 run instances, etc., there is some technical jargon that essentially says, I want to launch this specific type of machine. That one is a Linux AMI with CentOS, a Linux version in it. I want to launch 3 of them in EU West 1A and 5 of them in EU West 1C. The ones that are launched in the A availability zone will be small instance types. The other ones will be medium instance types. So you can see that we are already digging into some technical details, but I don't want to scare you. All of those things, if you are tech savvy and if you are familiar with AWS, you know exactly what you want to launch, you know exactly what type of virtual machines you need, etc. But if you are not, there is a web interface, so a visual interface that allows you to perform those operations very easily. And on the next slide, this is an example where you run machines also across regions. In this case, we want to launch 2 additional machines in 2 additional availability zones in North Virginia. And why should a customer do this? Because when you run machines across regions, you are essentially creating an infrastructure that can span across the globe and serve customers from the US and from Europe or from elsewhere in this case. And another example is that, of course, you want to authorize a specific port on your web servers in this case with the EC2 authorize API call. And you can also create auto-scaling groups. Those are essentially groups of virtual servers that automatically scale based on, in this case, the amount of CPU traffic that you have on those machines. So again, this is just to give you an idea of the completeness of the services that we offer. But of course, you don't need to know everything to get started. Actually, getting started is very easy. And as an example, in the next slide, you can see 2 screenshots of the web console. You can log in with your credentials and then decide which service you want to start with. For example, EC2, which is a service that provides you with virtual servers on demand. And then the screenshot at the bottom right shows you how the EC2 web console looks like. And from here, you can simply click and launch an instance or multiple instances, and then get started with your cloud computing infrastructure. So let's step away a little bit from those technical details. Let's try to understand why customers are interested in using cloud computing, and in particular, using Amazon Web Services. There are some important benefits. The first one is that instead of investing huge amounts of money upfront to purchase infrastructure, you can just spin up the capacity that you want and pay that capacity by the hour, or as we say, pay as you go. This, of course, brings an amazing benefit because with on-premises infrastructure, you have huge capital investments, you have to deal with physical installation. or even if you are using co-location services and you are somehow detached from the physical infrastructure itself, you still deal with the limits of a physical infrastructure. On Amazon Web Services, you don't need any investment to get started, and you only pay for the infrastructure that you use. And as an example, IDC, analyzing some customers that are using AWS, they discovered that on average, every customer replaces 400 servers when moving to the cloud. And this is an important testament of how important, how useful cloud computing is for those customers. Another advantage is economies of scale. So since we have a huge global footprint, we have economies of scale, and we pass those cost savings to our customers. So for example, in the next slide, we have some of our use cases. Samsung, they launched their Smart Hub application. This is essentially an application that runs on Samsung TVs worldwide, and they decided to use Amazon Web Services instead of building physical infrastructure. By doing so, they saved $34 million just at the beginning, and they also saved 80% of their operational costs. So this was a huge cost saving for Samsung. Commonwealth Bank of Australia saved tens of millions of dollars just by migrating a dozen of their internal apps from on-premises to Amazon Web Services. Foursquare uses AWS for many things, among which analytics. And just by moving to AWS, they reduced their costs by 50%. So those are some examples of how important and useful the adoption of cloud computing is to enable either existing businesses or new businesses to achieve a lot without spending too much. And another analysis of IDC discovered that there is a 70% lower total cost of ownership over the course of 5 years per app when you use Amazon Web Services compared to the traditional on-premises infrastructure. So this is what happens in reality. So economies of scale, they bring a lower variable expense than compared to what companies can achieve themselves. This in turn brings more AWS usage because we reduce prices, we get more customers, and therefore this drives usage. We build additional infrastructure, we reach additional economies of scale, and then we keep lowering costs and then bringing those costs to our customers again. And in fact, we had more than 30 price reductions since 2006, so in the last 5 years. In the last 7 years since we launched AWS. And this is a testament of how important it is for us to continuously win the trust of customers. Another important, very important benefit is the elastic capacity that you have. So you don't need to guess how much infrastructure, how many servers, how much storage you need for your applications or your service, because you can just quickly spin up instances whenever you need. So in a typical scenario, traditional infrastructure, you have a predicted demand, the dotted line that you see here, but then the actual demand can be very different, which means you either waste a lot of capacity that sits there idle, or you're not able to provide enough capacity for your customers, and therefore those customers will be very unhappy with your service. With cloud computing and Amazon Web Services, you can easily adapt your capacity exactly to your specific needs. And you can also automate this. You were seeing before some of the command line interface instructions to create auto-scaling for your capacity. But there are, of course, many other even simpler ways to do that. Another advantage is that you have speed and agility. You can spin up instances or use storage in just a few minutes instead of waiting for weeks for your deployments to be ready. And as an example, we usually like to talk about real-world examples, so real customers. Lionsgate, for example, is a customer that is able to reduce significantly the amount of time needed to deploy their apps from days or weeks to just a few hours or even less than that. And there are many other examples of customers that vastly reduced their deployment time just by moving to AWS. So speed and agility, of course, is also very important because sometimes when you launch a new project or when you are dealing with customers, you need to act very quickly. Let's imagine that you're launching a marketing campaign and for some reason the marketing campaign is very successful. You need to deploy additional infrastructure very quickly because you want to keep the momentum going. On AWS, you can spin up that infrastructure in just a few minutes. You decide how many machines you need, how big they should be, or you just add storage, and that's it. You don't need to wait the usual call my provider, wait for the physical infrastructure to arrive, set up everything, etc. So it's very fast. And of course, on premises, you have millions of dollars invested in infrastructure, while on Amazon Web Services, you can experiment with different deployments or different architectures very quickly, which means you can also fail quickly and at a low cost. For example, if you're trying out a new service or a new design or a new architecture for your infrastructure, you can easily and quickly experiment. Optionally, you can also fail and just recover from that failure very quickly because you can spin up additional infrastructure, destroy the infrastructure that you just created if it's not what you wanted, etc. So this flexibility, this speed and agility is a very key element of today's cloud infrastructure. Another reason why customers are using cloud computing is that you can focus more time on doing your business instead of focusing in the what we call the muck of IT management or the undifferentiated heavy lifting. So, for example, we take care of running data centers, providing power, cooling, cabling machines, setting up networking among those machines, building racks, installing servers, installing storage, all the labor associated with this. So you don't have to do this by yourself, and you can spend that time focusing on your business instead. You can also go global in minutes. Remember, I was showing you a map of our regions. Let me actually go to this map now. Those are regions. The stars are the edge locations. You can reach to a global audience in just a few minutes, and you can take your application and deploy that globally in just a few minutes. This is an amazing feature. Imagine, for example, Facebook games or mobile apps or services that just reach instant popularity. They can quickly scale globally in a few minutes on AWS. This is something that was not possible before. Just to give you an idea of the elasticity that you get on Amazon Web Services, this is Amazon.com itself, one of the customers of Amazon Web Services. And this is the typical weekly traffic to Amazon.com. As you can guess, a lot of traffic happens during the day, and late at night there is much less traffic. But this is actually something that gets even worse in the month of November, where there is a spike in the rush for buying Christmas presents and things like that. So there is a huge difference between a normal traditional workload and one you have on a few specific days. And as you can guess, in a traditional environment, we will need to provision capacity at a level like this one, the blue line that you see at the top. This will mean that a lot of capacity will be wasted. And in our case, in the case of Amazon.com, this will be approximately 3/4 of the total capacity. That capacity will be just wasted. Instead, Amazon.com was completely moved to Amazon Web Services on November 10th, 2010, so 2.5 years ago now. And that's the date when the last physical web server of Amazon.com was turned off. And of course, something else was turned on Amazon Web Services. And actually, the year after that, just almost like a year after, we also turned off the last web servers supporting the European business. So Amazon.de, Amazon.co.uk, Amazon.fr, Amazon.it, the Italian one. I'm Italian, so I was particularly proud of this change. And again, if you think of the traffic now, you can probably see the blue line that just follows the capacity needs that Amazon.com has, that's what happens. There is essentially almost no waste of capacity for Amazon.com now that they run on Amazon Web Services. And this is another example of a company called Animoto that provides a very simple service. You upload your pictures to the website. They create a video with effects and animations based on the music that you want in the video. And a few years ago, they were using 40, 50 instances. Then they launched a Facebook app. They did some modifications, and it went immediately viral. It was featured on TechCrunch, on Slashdot, and other sites. And essentially, their number of EC2 instances grew to a peak of 5,000 instances in just a few days. This is an example of the flexibility and elasticity that you can get when you use Amazon Web Services. So now it's time to take a closer look at some of the web services that we provide. I will try to be very quick on this one. I want to make sure we have time for questions, but I also want to make sure that I mention at least some of the services that you should be aware of. So typically, we have a reference model in which we divide different services at different levels. So the AWS Global Infrastructure is the physical infrastructure. Remember the regions and the availability zones and the edge locations that I mentioned earlier. Then if we move higher in the stack, of course, availability zones are essentially a mapping of physical infrastructure. And then on top of availability zones, in addition to availability zones, we have edge locations, which we use to deliver content, either static content or video streaming content to end users. And then you can connect to this global infrastructure by using multiple means. You can use Direct Connect, which is a dedicated connection between your IT infrastructure and the AWS data centers. You can use a VPN connection, either a hardware VPN connection or a virtual VPN connection to connect securely to AWS. You can also use the Virtual Private Cloud service, which is an isolated section of the AWS cloud that allows you to launch resources such as virtual servers or storage or load balancers in a virtual network that you define, and you have complete control of the virtual networking environment and the security of this environment as well. And then you can also use Route 53, which is a domain name system service. Of course, this is a very reliable and cost-effective way to have your websites, your domain name servers, to be used on Amazon Web Services and to run on Amazon Web Services. So, for example, if I have my website, let's say brunozzi.com, my personal blog, I can use Route 53 to route the traffic from anywhere in the world to specific locations in the Amazon Web Services infrastructure and then serve content for that website. But of course, this can be used also for very important production environments or enterprise use cases. Then we have the compute services. The main one is called Amazon EC2 or Elastic Compute Cloud. We offer you different types of machine instance types, small, micro, medium, large, extra large. And we offer several services on top of it. We give you the ability to import or export virtual machine images. You can monitor those machines. You have full control of these machines, essentially what we call administrator rights. So you can log in as a root or administrator and perform any operation of those machines. Then we have an additional use case as an example, the Guardian, which is a media company in the UK. If you can read on the slide, this is from Mike Brecken, the Director of Technology Development. For them, it takes less than 10 minutes to set up a new instance on Amazon EC2 and maybe another 20 minutes to connect the infrastructure, etc. So the lead time is half an hour. Usually this would take several weeks to get budget approval and everything else. So this is an example of how you can leverage the compute services for your infrastructure in this case. You can also take advantage of the auto-scaling. This is a feature that allows you to decide how, when, and in what numbers your EC2 machines should scale over time. For example, you can say, I want a minimum of 2, or in this case of 4, a maximum of 200 machines, and I want them to scale based on the CPU utilization. So essentially, your infrastructure would automatically adapt to your specific needs. Elastic Load Balancing is a service that allows you to take incoming traffic and then spread this traffic across multiple machines, possibly served by auto-scaling as well. So especially in the case of customer-facing or internet-facing businesses, whatever amount of traffic you get from the outside, you can use the Elastic Load Balancing to spread this traffic and then have EC2 machines serve this traffic and eventually scale if there is a huge demand or spike in traffic. We also have storage. The main service, the most popular one is S3. It's a very durable internet storage. It offers 11/9 of durability, or as we say, 99.9999999%, which in human terms, in more understandable terms, it means that if you have 1 million files, on average, you lose one file every 100,000 years. So this is the level of durability that S3 was designed for. And there is unlimited storage. The limit is for the single object is 5 terabytes, but there is no limit in the amount of storage that you use. For example, a very popular service like Dropbox runs entirely on Amazon Web Services, and they were publicly stating on their blog a while ago that they're using several petabytes of storage on Amazon S3. And of course, S3 has many features, many special services. For example, you can physically import or export to and from S3. You can set up automatic object expiry dates to remove old objects after a certain amount of time, etc., etc. So this is another example, Spotify, which is a very popular service to listen to songs for free. It's a UK-based company that recently was launched in the US as well. So Spotify uses S3 very heavily, very extensively. They needed a storage solution that could scale very quickly, and of course they turned to Amazon S3, which is the most mature large-scale product from their point of view. And of course, this also helped them expand in the US when they added the US service as well. We also have virtual block devices. We call them Elastic Block Store. Now the actual maximum size has been extended to 4 terabytes just a few days ago. And essentially those are virtual drives that you can mount to instances and then use them with any file system of your choice. And of course, the advantage of EBS, as that's how we call it, the Elastic Block Store, is that it's automatically replicated within an availability zone. You can probably approximate this as like having 2 disk drives in a mirror RAID configuration, which means that if there is one single hardware failure, which involves one of your virtual Elastic Block Stores, we actually detect it, and then we replace the missing copy by using the other copy that is still running. So there is some redundancy built in Elastic Block Store, but at the same time, there is also an easy way to snapshot EBS volumes into Amazon S3, of course, for more durable backups. We also have a cold storage, as some people call it, a cold storage service, which we call a Glacier. Glacier is a very low-cost, highly durable storage service. The main difference between Glacier and Amazon S3 is that on Glacier, when you store files on Glacier, if you need to retrieve those files, there is a lead time of a few hours in order to retrieve the first byte. So we essentially give you a much higher latency in exchange for a much lower cost of storage. So this is typically used for archiving. We also have relational database services. You can run them on Amazon EC2 and manage them by yourself, or you can ask Amazon Web Services to manage those databases for you. And we currently offer Oracle databases, MySQL databases, or Microsoft SQL Server databases. And essentially, it's very easy to get started by just launching an Amazon RDS, or Relational Database Service instance, and then start using it immediately, just after a few minutes. And the database services, in this case RDS, also has features such as multi-AZ. AZ stands for Availability Zone, and multi-AZ means that we automatically replicate your database across 2 availability zones. So you essentially have one master database and one hot standby replica, the exact replica of your main database. If anything happens to the main database, the other machine will automatically take over and then start serving customers. And SIGA is one of the examples of customers that are taking advantage of this very easy to use feature. DynamoDB is what people call a NoSQL database offering. It's a key value store, and it allows you to quickly create fast and predictable performance databases that are also fully distributed and also fault tolerant. They run on SSD drives, so it's very fast. And in fact, DynamoDB gives you a single-digit millisecond response time whenever you write or read on DynamoDB. We also have a queuing service. We call it Amazon SQS, or Simple Queue Service. This is maybe for the tech savvy in the audience, this is a very useful service when you want to orchestrate and send messages across different services in your cloud. And this is, again, a reliable, highly scalable queue service that you don't need to set up. You can just use it and pay very little money for millions of messages in your queues. We also have a service called the Simple Workflow, which allows you to coordinate processing steps across applications. So, for example, if you have a workflow, for example, you have one task that should be followed by another task and then by another task, you can essentially create a workflow with the Simple Workflow service and then have this specific service maintain application state across even complex workflows and also track the execution of individual tasks. And as an example, NASA, and this is a picture of the Mars rover, is using the Simple Workflow extensively to essentially handle the different pictures that are taken from the rover, left image and right image. They are warped and then stereo meshed, and then out of those pictures, they create a 3D map that is then a tile. And this is an example of the several pictures that you get and the result of the essentially the patching all of those pictures together. And all of this is done with the Simple Workflow on Earth. It is not done on space. And those are some of the other cool pictures of the NASA Mars rover, as well as live pictures that were taken just a few months ago. Another application service that is now getting very popular is cloud search. So you might think that search is something very simple, but actually when you want to implement search for your website or for your service or application, there are many features that you might need for search. For example, faceting or stemming or synonyms or stop words, etc., that are very hard to implement by yourself. And again, listening to customer feedback, as we usually do, we created the Cloud Search service, which allows you to very quickly, in just a few clicks, to get started and create a search domain, and then use Cloud Search to provide those features for your search needs. CloudFront is a content delivery service. Remember the little stars on the globe that I was showing you before? Those are edge locations. So CloudFront allows you to take any type of content, either static content or video content that you want to play in streaming, and then serve this content worldwide to a global audience by serving content, for example, to specific edge locations and automatically direct traffic to the closest edge location. So for example, if you have a customer that is in nearby Paris, the Paris edge location will be used to deliver content. Therefore, the experience for the customer will be, of course, much better. Elastic MapReduce allows you to manage a Hadoop cluster automatically, and by integrating also Amazon S3 for the storage and DynamoDB as well. And you can also leverage analytics tools and reportings to essentially get analytics on the results of your Hadoop jobs. So for the non-technical people, this is essentially a way to run data-intensive applications across multiple machines in a very easy way. Elastic Beanstalk, this is an amazing service, and as you see, we are moving up in the stack. We're now at the deployment and administration layer, so the higher one. Elastic Beanstalk allows you to take your application, either a PHP or Java or Python, Ruby or .NET application, and just deploy this application on Amazon Web Services. So if you are scared of all of those acronyms and names, and if you're scared of the complexity of using AWS, if you're just a developer that wants to run its own application on Amazon Web Services, you can just go to Elastic Beanstalk, deploy your application, and we take care of creating the infrastructure needed for this application to run. Then you can use the CloudFormation tool, which is a way to create templates of your deployments on Amazon Web Services. And you can use those templates or stacks to repeatedly deploy specific stacks or specific infrastructure, even across different regions. And last but not least, you can manage identities, permissions, roles, and essentially the security of your applications, of your servers, of the access to your AWS resources by using the Identity and Access Management service. This gives you very fine-grained control of user rights with AWS. So there are many other services that I didn't even mention. The AWS OpsWorks is one of the latest, but many others as well. So we don't have time to cover all of them. Just very quickly, I will give you a quick idea of one of the latest that has been recently introduced. And this gives you an idea of the type of innovation that we are bringing in the market. So Amazon Redshift is a service that allows you to do data warehousing without spending the huge amounts of money that were typical in this specific vertical. So we drastically reduced the cost of running traditional data warehouses. And in fact, for example, on Amazon.com itself, we started a test a while ago in which we compared an on-premises retail data warehouse, and then we ran our test on Amazon Redshift. We were able to have 10x faster results at a tiny fraction of the cost. And we have an additional service that I want to mention, the AWS Data Pipeline. It allows you to orchestrate services for data-driven workflows and create automated data flows. For example, if you have your DynamoDB tables and you want to programmatically back up those DynamoDB tables into Amazon S3, you can create a data pipeline which gives you a visual tool that allows you to take the source, the destination, and the type of operation that you want to perform, and automatically do this on the fly. And again, one of the latest services, the Amazon Elastic Transcoder. As the name implies, if you need to transcode videos in multiple formats or in multiple different types of dimensions or sizes, you can do it automatically now with the Amazon Elastic Transcoder. Now, the number one enterprise question is usually around security. Is the cloud secure for my apps and data? We actually take security very seriously. We have a number of certifications and several external audit companies that regularly test our infrastructure. And this is essentially a way to tell our customers, your application is very secure on the cloud, and we are doing our best to keep this as our number one priority. And as an example, I want to read just the quote on the left from Gus Hunt, the CTO of the CIA. You basically turn yourself into a polymorphic surface to which the attack guy has a much tougher time getting at. That ultimately is the real key advantage to drive security and make things much better for us across the board. So you can imagine that if we can win those type of praises from CIA or government agencies or from big enterprise customers, it is real that we are focusing a lot on security. But then the second enterprise question is, how does it work with my on-premise environments, so with the existing environments that I have? And this is what people sometimes refer to as a hybrid cloud. So you can have your corporate data center, it's the figure in the center, and then you can easily extend your corporate data center into the cloud by just adding capacity and connecting those different pieces all together by using, for example, VPC or Virtual Private Cloud, and then run those applications and also map those applications into your existing data center, even without telling your users that those applications are partially or totally running in the cloud as well. So we provide with private network connections. We allow you to migrate workloads in and out, to and from on-premises and cloud environments. And we also have several tools that let you integrate with existing identity and access control systems. As an example, if you are using Microsoft Active Directory for your users, you can easily integrate that with IAM in order to authenticate your users to AWS without any intervention or manual customization. So as a summary, just to wrap up very quickly, those are the main advantages of using cloud computing, replacing capital expenditure with variable expense, enjoying economies of scale, the elastic capacity and being able to scale whenever you need, the ability to deploy in just a few minutes, the ability to focus on your business without wasting time in undifferentiated heavy lifting, and also the ability to go global in minutes instead of weeks or months. So this is a link for a survey. I invite you to click on this link later or now to take a survey about this webinar. And this is the last slide. This is, of course, the starting point for you if you want to get to know more about AWS. And now we have, I think, a few minutes for some of the questions. Thank you very much.
Thank you so much, Simone. Before I hand it over to Natalie here, I just want to make sure that we do get that survey launched. So I'm going to go ahead and push it out again right now. And now I will hand it to Natalie to go through the questions.
Thank you, Aurora. We have got a lot of questions here from people on the line. So I will start with a question here from Clinton, who asks, does Amazon offer services to help companies plan, migrate from traditional data centers to AWS?
Sure. So first of all, we have a huge ecosystem of partners. If you go to aws.amazon.com, you can see there that there is a section dedicated to our partner network, and which means you can find specific companies that can help you consult, etc., to help you migrate. But we also have a professional services team, which might be useful if you need a much deeper insight into AWS. So those are the types of things that we offer. And we also have specific services that quickly and easily help you migrate from traditional data centers to AWS by yourself. For example, you can move VMware images from on-premises data centers to AWS. You can move workloads. You can move applications. And on the website, on the aws.amazon.com website, there are many sections many details in the architecture section. You can just go to aws.amazon.com/architecture, and that's probably a good place to start. There are some sections that talk specifically about migration.
Great, thank you. The next question I have is from Alexi, and the question is, please elaborate on the security of EC2 instances. Are there any firewalls available? Can we configure them? Do we need to somehow consider security when we operate an instance?
Sure. So first of all, there is a very high level of security by default on EC2. But we also have a security model that we call a shared responsibility model. And let me tell you what this means. When you launch an Amazon EC2 instance, you have full access to this instance. So you are administrator or root on that instance. And we don't have access to that instance directly, which means that you are responsible for that instance. You are responsible for patching that machine, for regularly updating that machine. And if you fail to do so, that machine might be attacked from the external. So this is something you have to take care of. But at the same time, we provide you with tools and services that make it very easy for you to have a very secure environment in on your EC2 machine. For example, by default, we have a firewall for built-in traffic. We call it security groups. And by default, security groups are closed on all ports. So when you launch an EC2 machine, and if you don't know about those details, there is essentially no risk of your machine being accessed by someone from the outside because there is no port open. And then you will have to explicitly open ports. For example, if you want to run a web server on that machine, you want to open port 80. And if it's an Apache web server, and if you want to open SSH access because you want to manage that machine, you need to open port 22 on the security group for that machine. And there is also a security section on our website. You can go to aws.amazon.com/security, a better sense of how security works and what tools you can use. And there's also a very extensive white paper that is regularly updated that tells you all about the security on Amazon EC2 and on other services as well.
Thank you. Okay, the next question I have here is from XKE. Can you speak to how easy or hard it is to migrate an app from another solution to Amazon Web Services?
Sure. So I would say we have to divide it into two different use cases. Typically, if you have an application that is built to run on, let's say, one or more Linux servers or Windows server, in that case, it's incredibly easy to migrate that application to AWS because you can just recreate the same environment on AWS and then just deploy your applications there, usually with no change in the application code and maybe some minimal change in the way the different applications interact together. The second example is when instead you have a legacy application which has a very heavy dependence on a specific hardware or a specific, for example, specific operating systems or versions. We typically offer most of the operating systems on the market, but if you have a legacy old application written in Fortran that runs on a mainframe, in that case, for example, that is something that you cannot easily port to Amazon Web Services. But what I found is that in most cases, I would say almost all cases, there is essentially no high barrier in migrating an app from another solution to Amazon Web Services.
Thank you. Our next question is from Nick, and Nick asks, as a startup with limited resources, we will have to learn AWS in-house. What level of support can we expect as a small business while learning AWS? What resources are there out there to ramp up?
Yes, this is actually a great question because it lets me mention something that I really like, one particular service that I really like. So we have premium support for Amazon Web Services, and premium support comes in 4 plans. The base plan is free. The developer plan is $49 a month. The business plan and the enterprise plan, they are at the minimum $100 a month or $400 a month. But in particular, my suggestion would be when you start using AWS to go for either the developer plan, which is just $49 a month, or the business plan, which is either $100 a month or 10% of your AWS bill. Even if you think, well, this is a reasonable amount of money just to get started, actually the benefit of using the premium support is that you can actually ask questions and get support on anything essentially 24 hours a day. So let's say you are starting with AWS, you're launching EC2, and for some reason you cannot connect to the instance. You can ask support that will tell you, hey, can you check the security groups? And then you check, and then you realize, oh, I didn't open port 80 and port 22. That's why I'm not even able to access my machine. So you can use these as a way to learn and to fix mistakes along the way. And you can also use the learning center that we have. So if you go to aws.amazon.com, there is extensive documentation and also a learning center that allows you to get trained and learn about AWS specifically. But I particularly like the use of support, not only when you are in production and you want to have premium support on your site, but also when you start learning. I think it's a great way to learn, and it's, I would say, relatively inexpensive, because for just a few dollars a month, you can get answers to even hundreds of questions a month if you want to. And it's nice because you can try it out. If you don't think you like it, or if you don't think it's useful, you can just sign out from premium support whenever you want.
Thank you. Okay, this next question is from Tony. Tony asks, how should applications be designed or written to best take advantage of AWS's elasticity?
Sure. This is actually a general principle of distributed applications. So it doesn't just apply to AWS, but essentially it applies to any modern distributed application. So those are good design principles that you should use no matter if you use AWS or not. And usually there are a few rules. I will answer quickly. Of course, the answer could be much longer, but briefly, the concept is you want to have independent pieces of your applications that can easily scale independently. So essentially, you want to have a loosely coupled system. You want those systems to talk together using APIs or using a messaging system. For example, SQS and the simple workflow that I mentioned before are two very good components that you can use for that. And when you do this, it means that you are designing your application to take advantage of a distributed environment. And when that distributed environment is elastic, like in the case of AWS, it also means that you can quickly scale the infrastructure that you're using in and out, up and down, so you can increase the size of individual machines, or you can increase the number of machines running for that specific service just at will. So you can use auto-scaling, you can use other meanings to do so. And essentially by doing this, you really create a flexible, reliable, robust, and highly available application environment for your business.
Okay, thank you. I've got a few product-specific questions here, so we'll take 3 more questions. This one is from Alex, and he says, what is the easiest way to connect to Glacier Storage? How is the movement handled from storage to Glacier?
So right now, Glacier offers easy APIs or integration with Java environments and .NET environments to quickly migrate from Amazon S3 to Glacier. And in the coming months, we will add additional support for even easier ways in the management console as well to migrate or automate the archiving of specific files to Glacier. But right now, even just now, you can easily programmatically schedule the movement, let's say, or the archiving of your S3 files to Glacier by just setting up some policies. And everything is well documented on the Glacier documentation. If you go to aws.amazon.com and then you select Glacier among the services, and then you go on the documentation page, you can see that one of the sections actually just describes how to automatically archive files from Amazon S3 to Glacier.
Okay. The next question is about load balancers. This is from Brees. He says, with your load balancers, do you route users to the closest region automatically?
Sorry, do you route? I didn't get the last part of the question, sorry.
Oh, sure. With load balancers, do you route users to the closest region automatically?
So we don't, but there is an easy way to do that in conjunction with Route 53. So essentially, I will give you a quick answer, and all the details are again in the documentation. If you have a load balancer, that load balancer has a DNS name that is essentially a global name, but by itself, it doesn't let you reroute traffic based on a region. For example, American or U.S. traffic to a specific load balancer in Virginia, and maybe European traffic to a load balancer in Ireland. But if you use a Route 53, you can use a feature called weighted routing, which lets you specify that traffic should be rerouted to either one of those two or more elastic load balancers based on latency from the customer endpoint. So essentially, you will obtain the feature of rerouting traffic to the closest elastic load balancer based on latency. So this feature can be enabled by using Route 53 in conjunction with elastic load balancing, and is very well documented on the documentation page.
Okay, and our final question is about our Simple Email service. So is Simple Email service only for sending emails, or can it be used to provide customers with a regular mailbox?
No, so the Simple Email service is an email sending service. So it's intended to send even millions or billions of emails. And it's, of course, very easy to use, very quick to set up. It lets you specify many features of your email sending decisions for marketing purposes. You can specify specific metrics, etc. But it is not an email server. So if you need to manage your company email, in that case, you will need to run either Microsoft Exchange or any of the other Linux-based mail systems on Amazon EC2. So SES is a different service, and it's actually a very popular service for marketing campaigns or for newsletters, etc. And it removes the need to manage very complex architectures that, of course, involve mail servers as well in this case. And there's also a blog that is written by the SES team. I think if you just search online for Amazon SES blog, it should be the first result on your page. And on that blog, the team also shares many insights and many tricks on how to use SES more effectively.
Great. Thank you, Simone. So we don't have any more time for any more questions, unfortunately, but we will follow up with you separately to make sure that we get all of your questions answered. Any final words before we close it out, Simone?
Yeah, just I want to thank you, everybody, for attending, and I really hope that this was useful. There was a lot of information, so hopefully you will be able to digest everything. And of course, I really hope that you will go to aws.amazon.com and start learning about it. You can also reach out to me on Twitter. I'm Simon on Twitter. So just feel free to reach out and let me know what you think, or if you have any additional questions. And thank you very much, Natalie and Aurora, for setting this up and for helping us with the logistics.
And with that, we'll go ahead and close it out. I just want to remind everybody you will be receiving a follow-up email, and that'll include a URL to the YouTube on demand, so you can watch it again if you'd like to, and also a copy of the slides, or a URL so you can see a copy of the slides. And please do fill out our survey, because we appreciate all your feedback, and we do take it very seriously. And with that, I'll say goodbye and have a wonderful day or evening wherever you are. Thanks so much.
Goodbye, everybody.